Hello students, today we are going to start our discussion about the chapter carbon and its compound, which is actually one of the most important chapters for class 10th chemistry. But for the year 2020, because of the COVID-19 pandemic, most of the portion of this chapter has been deleted from your syllabus. Still, I would like to suggest all class 10th students at least once go through it completely, thoroughly, and then prepare for your exam only the syllabus which is required. All right, because this chapter is going to be very relevant for your further studies in the higher classes. Okay, at the same time, it is very important chapter from your day-to-day life. As far as carbon is concerned, in our periodic table, it is the sixth element with atomic number 6 and its electronic configuration is 2, 4. Yeah, beta, carbon is mostly found in coal, right, as a natural component. That's why the term, Latin term carbo has been given to it and the name was carbon, right? It's a non-metal, first thing we have to observe. And second, the amount of carbon present in the Earth's crust and in the Earth's atmosphere is very less. Actually, the huge amounts of carbon is present in living things, within the living organisms like plants, animals, etc. These all are made up of carbon compounds, which are also known as organic compounds. Why? Because these compounds are found inside the living organisms. That's why the name organic compound is given. You will be amazed to know that initially there was a theory which was saying that these compounds cannot be synthesized in the laboratory. But nowadays we know that, initially it was assumed under the vital force theory that organic compounds can only be synthesized in the living organisms, in the bodies of the living organisms, inside the cells of the living organisms. But once a scientist named Frederick Wöhler was heating ammonium cyanate, which is a well-known inorganic compound, and accidentally he formed urea, which is a well-known organic compound, right? So one organic compound was formed in the laboratory. Then scientists came to know, oh, if one is formed, then other can also be formed, and we have started trying for formation of these compounds. And today the condition is that every day more than 5 to 10,000 new organic compounds are synthesized. Okay, let's move forward. A large number of things which we use in our daily life are made of carbon compounds, beta. For example, our fruits and vegetables, right? Sugar, tea, coffee, pulses, grains, etc. On the other hand, fuels like wood, coal, kerosene, LPG, natural gas, CNG, petrol, diesel, etc. all are carbon compounds. Carbon element plays a very important role in our daily life. We can test the presence of carbon in a material on the basis of the fact that carbon and its compound burn in air to give carbon dioxide. आप किसी भी organic compound को combustion कराएंगे बेटा, you will get carbon dioxide gas. And you know very well from the knowledge of your chapter 1 chemical reactions and equations that carbon dioxide gas turns lime water milky. What is lime water? Lime water is calcium hydroxide, if you can see on your screen, CaOH whole twice, which in presence of carbon dioxide reacts to form calcium carbonate, CaCO3. CaCO3 is insoluble, that's why we call it, means it is insoluble white substance. So your test tube or beaker, wherever you are conducting this particular reaction, appears milky, it starts appearing milky. Okay. So this is a test reaction for carbon dioxide that it turns lime water milky. Highlight this point. Carbon always forms covalent bond. Yes, beta. Carbon always forms a covalent bond. Why? Because its electronic configuration is 2, 4. Outermost shell में इसके पास 4 electrons हैं. So 4 के case में to release 4 electrons or to receive 4 electrons is quite a difficult task for carbon. That's why it shares the 4 electrons, and the bond which is formed by the sharing of electrons is called covalent bond. That's why carbon always forms covalent bond, and it forms 4 covalent bonds, right? That's why we say that carbon's valency is 4, or we say it is tetravalent, right? We'll see further in this lecture. Yeah, carbon is tetravalent, as just now I have told you. The other most important property of carbon is self-combining capacity. This is called catenation. Please keep this word in your brain, catenation. What is catenation? The peculiar ability of carbon element to undergo self-linkage and form long chain compound. The self-combining capacity of carbon. See, the self-combining capacity of carbon atom to form long chains is useful as because it gives rise to an extremely large number of carbon compounds, that is organic compounds. Carbon can combine with itself in a number of ways, in a straight line, to form a branch chain compound. It can form cyclic compounds, right? It can form cyclic compounds as well, right? So we'll see in this chapter later. This thing is clear to all of you? Yes, so this was all about the self-combination properties of the carbon, that is catenation property. After self-combination, beta, we have to take care of occurrence of carbon. How do carbon occur in the nature? Carbon is found in free state as well as in combined state. In free state, it is found in the form of diamond, in the form of graphite, right? And also in the form of Buckminster fullerene. Got it? In combined state, it can be found in the form of carbon dioxide in atmosphere, in the form of carbonates, limestone, marble, chalk. These all are carbonates. Fossil fuels like coal, petroleum, natural gas, and organic compounds like carbohydrates, fats, proteins, wood, cotton, wool, etc. All these are carbon compounds. In all these substances, carbon is found in the combined state. In the free state, it is found in three forms: diamond, graphite, and Buckminster fullerene. Okay. Allotropes of carbon. Beta, what are allotropes? When one element is found in different types, when one element is combined in different ways to give different substances with different properties, right? Same element. Then the phenomena is known as allotropy, and the different substances which are formed by the different combination of the same element is called allotropes, or are called allotropes, right? So what are the allotropes of carbon? Carbon के allotropes हैं बेटा diamond, graphite and Buckminster fullerene. Okay. Let's see in detail. What is diamond? Diamond is actually a colorless transparent substance having extraordinary brilliance. Okay. Diamond is extremely hard. It is quite heavy. It is hardest natural substance known. Diamond does not conduct electricity. Please keep this thing in your brain. Diamond does not conduct electricity. Why? Because in case of diamond, the carbon is forming the tetrahedral structure. What sort of structure? Tetrahedral, where all these bonds are at 109 degree, 28 minutes. 109 degree, 28 minutes. Okay, this is the angle in the diamond. Yeah, we burn diamond in oxygen. Beta, actually it is very hard with very high MP and BP, but in case if we are able to burn it, then it will burn with to form carbon dioxide. okay, because it is nothing but 100% pure carbon. This shows that diamond is made up of carbon only. The carbon dioxide formed by burning of diamond turns lime water milky. Since diamond made up of carbon atoms only, its symbol is taken to be C, right? Graphite, another allotrope of carbon, is grayish black opaque substance. You can see this is your graphite, okay. बेटा डायमंड के केस में स्ट्रक्चर वाज टेट्राहेड्रल, ध्यान रखिएगा, आपकी बुक्स में नहीं मेंशन है तो नोट कर लीजिएगा. डायमंड वाज टेट्राहेड्रल. While in case of graphite, the structure is said to be hexagonal flat layer structure. Hexagonal flat layer structure like this. ये hexagon के फॉर्म में होते हैं. Plus each carbon is forming 3 bonds. You can see यहाँ पर इस कार्बन को देखिए, it is forming 3 bonds, right? So obvious सी बात है बेटा, one electron is free, and because of the presence of this free electron, ये delocalized pi electron pair रहता है, right? And this, because of this delocalization, graphite conducts electricity. All right, any problem? Okay. So graphite is lighter than diamond. Graphite is soft and slippery in touch. It conducts electricity. Question आता है, why does graphite conducts electricity? So I have already told you that graphite conducts electricity because of the presence of free electron or delocalized pi electron. ठीक है? If we burn graphite and oxygen, then only carbon dioxide gas is formed and nothing is left behind. This shows that graphite is also made up of carbon only, and uska bhi symbol is taken at C, right? You can see the structure of diamond now. ये देखिए tetrahedral structure है. You cannot draw whole of the structure, but you can draw at least this much. Okay? Any problem? There is also a question that why diamond is so hard. So the answer is diamond is so hard and rigid because of the large number of covalent bonds. वहां पर bonds बहुत ज्यादा हैं, ठीक है? Diamond is the non-conductor of electricity because we know that carbon has 4 valency और diamond ने 4 bond बना रखे हैं, तो सारे के सारे इलेक्ट्रॉन तो यूज हो रहे हैं. No free electron is there, so because of the absence of free electrons, diamond does not conduct electricity. Since there are no free electrons in the diamond crystal, it does not conduct electricity. Clear? The structure of graphite, I have already told you that it is hexagonal flat layer structure. You can see hexagon जैसा बना हुआ है. These are hexagonic layer होती हैं और different layers के बीच में कुछ distance होती है. Fine. So this is called hexagonal flat layer structure. Got it? Any problem? Uses of diamond का बात करते हैं. Diamonds are used in cutting instruments like glass cutters, saw for cutting marble, in rock drilling equipment, etc. Diamond is used in making jewelry as well, right? Diamonds can be made artificially also because carbon का ही है. कैसे? By subjecting pure carbon under very high pressure and very high temperature. आप pure carbon लीजिए, उसको बहुत हाई प्रेशर और टेम्परेचर दे दीजिए, वो डायमंड बन जाएगा, नो प्रॉब्लम. These are called synthetic diamonds. Synthetic diamonds are small but are otherwise indistinguishable from natural diamond. Natural diamond और artificial diamond में कोई डिफरेंस नहीं होता है, सिर्फ आप उनके साइज में डिफरेंस देख पाएंगे. वो नेचुरल डायमंड थोड़ा सा बड़ा होगा और कंपैरेटिवली आर्टिफिशियल डायमंड स्मॉल होगा, अदरवाइज उनमें कोई डिफरेंस नहीं है. The diamonds which are not suitable for making jewelry are used in glass cutter, डायमंड स्टडेड सॉज एंड ड्रिल बिट्स, ठीक है, क्योंकि जो ग्लास कटिंग करने वाले आते हैं, आपने देखा होगा एक लाइन वो नाइफ का चलाते हैं और पूरा का पूरा ग्लास 2 टुकड़ों में हो जाता है, तो उसमें भी आगे डायमंड लगा होता है। अब अगर वो डायमंड का नाइफ लेकर के आएगा तब तो बहुत महंगा उसका बिजनेस हो गया, है ना, राइट। सो ऐसी कंडीशंस में जो जैसे ब्लैक डायमंड होता है, कुछ डायमंड इम्प्योरिटी की वजह से ज्वेलरी बनाने के लिए फिट नहीं होता है, उस डायमंड को हम लोग यहाँ पे यूज कर लेते हैं। फाइन, लेट्स गो ऑन। यूज ऑफ ग्रेफाइट। Due to its softness, powdered graphite is used as lubricant for fast moving parts of machinery, right? इसको हम high temperature lubricant की तरह भी use करते हैं। It is used for lubricating those machines which operate at very high temperature because ordinary lubricants वहां पर जल जाएंगे, right? Graphite can be used as a dry lubricant in the form of graphite powder for mixed with petroleum jelly to form graphite grease, ठीक है, कई बार इसको पेट्रोलियम जेली के साथ मिक्स करके ग्रेफाइट ग्रीस भी बनाया जाता है। ग्रेफाइट पाउडर कैन आल्सो बी मिक्स्ड विद अदर लुब्रिकेंट ऑयल्स, ओके। लुब्रिकेंट समझते हैं ना, जैसे आप साइकिल में ऑयल डलवाते हैं, बाइक में मोबिल पड़ता है, जस्ट टू इंप्रूव देयर इंजन्स फंक्शनिंग, जस्ट टू इंश्योर द स्मूथ फंक्शनिंग ऑफ देयर इंजन्स, ऑलराइट। Graphite is the good conductor of electricity due to which graphite is used for making carbon electrodes or graphite electrodes in dry cells and electric arcs. The black colored anode of a dry cell is made of graphite. जो black color का anode होता है बेटा, if someday because of your means driven by your mischievousness you would have broken a cell, you must have seen this graphite electrode. I hope all of you have done because I have also done. ओके, या कई बार ऐसा क्यूरियोसिटी आता है, ऐसा क्या है इसके अंदर जो इलेक्ट्रिसिटी जनरेट हो रहा है। फाइन, सो इन चाइल्डहुड वी ऑल हैव डन दिस एंड इनसाइड वी हैव गॉट दिस ग्रेफाइट इलेक्ट्रोड in dry cell and in the electric arcs. The black colored anode of a dry cell is made of graphite. The carbon brushes of electric motors are also made of graphite, okay. In electric motor and electric generator class 10th physics आप लोगों ने पढ़ा है ना, या graphite is used for making the cores of our pencils called pencil leads or black paints. Buckminster fullerene, very important for your competitive exams, not for board exams. Board exams में बहुत कम आता है इससे। Actually beta, Buckminster fullerene is an allotrope of carbon containing clusters of 60 carbon atoms joined together to form spherical molecules. Since there are 60 carbon atoms in a molecule Buckminster fullerene, so it is called C60. हालांकि इसके C52, C90, C80, C70, C मतलब नंबर हंड्रेड्स में भी चला जाता है, 250, 260 समथिंग करके एक है, राइट। सो दिस इज ह्यूज बॉल, बट C60 सबसे ज्यादा पॉपुलर है बकमिंस्टर फुलरिन में। इसका नाम बकमिंस्टर फुलरिन कैसे पड़ा, लेट्स सी। बकमिंस्टर फुलरिन इज अ फुटबॉल शेप्ड स्फेरिकल, देखिए फुटबॉल शेप का हो जाता है और ये सारे कार्बन के डॉट्स हैं। इट इज अ फुटबॉल शेप्ड स्फेरिकल मॉलिक्यूल विद C60 कार्बन एटम्स arranged in interlocking hexagonal pentagonal rings, hexagonal rings and pentagonal rings. Some rings are hexagonal, you can see, and at the same time some rings are pentagonal. Observable, yeah. So how many hexagonal ring and how many pentagonal rings are there in C60? That is an important question. There are 20 hexagons and 12 pentagons of carbon atoms in one molecule of Buckminster fullerene. Got it? This allotrope was named Buckminster fullerene after the American architect Buckminster Fuller because its structure resembled the framework of dome-shaped hall designed by Fuller or large international exhibitions for large international exhibitions. The arrangement of carbon atoms in Buckminster fullerene sorry, resembles a football. made of 20 hexagon and 12 pentagon panels, each corner of every panel representing a carbon atom. ठीक है, समझ में आ रहा है? Buckminster fullerene is a dark solid at room temperature. Room temperature पे बेटा ये dark solid होता है, and it differs from other two allotropes of the carbon, diamond and graphite, in the fact that diamond and graphite are giant molecules which consist of an underlying network, unending network of carbon atoms. Buckminster fullerene is a very small molecule made up of only 60 carbon atoms, right? डायमंड और ग्रेफाइट में बहुत सारे मॉलिक्यूल्स होते हैं, कार्बन एटम्स होते हैं, बट बकमिस्टर फुलिन के एक मॉलिक्यूल में सिर्फ 60 होते हैं, तो उनके कंपैरिजन में बहुत छोटा मॉलिक्यूल है. अगर आप बकमिस्टर फुलिन को जलाएं तो ये भी कार्बन डाइऑक्साइड प्रोड्यूस करेगा, जो कि लाइम वाटर को मिल्की कर सकता है. एज अ रिजल्ट वी कैन कम टू नो दैट इट इज आल्सो मेड अप ऑफ कार्बन ओनली. डायमंड इज एक्सट्रीमली हार्ड, ग्रेफाइट इज सॉफ्ट, जबकि बकमिस्टर फुलिन इज नीदर वेरी सॉफ्ट नॉर वेरी हार्ड. Okay. Other properties of Buckminster fullerene are still being studied, and we need not to know about that. Yeah, there are some problem questions. I hope you people will do it. Organic compounds. Now, what are organic compounds, beta? The compounds made of carbon are organic compound. This is a very old and poor definition, I can say. What is the correct definition? What is the present definition? So simply we can say, sorry. The hydrocarbons and their derivatives are carbon compounds, are the organic compounds. Now, what are hydrocarbons? What are their derivatives? We will see in this chapter. Now, I want to tell you that these things which I am going to discuss further in this chapter are major of that portion is deleted for your class 12th board examinations, class 10th board examinations of year 2020. But still, I want you all to go at least once through all these properties, okay? Because there may be some interconnected question. It may be important. It is actually important for your different competitive exams which you people are aware after class 10th. Yeah, so please take care of this thing. Compounds of carbon are known as organic compounds. Yeah, we'll come to see methane, ethane, propane, butane, CCl4, yeah, carbon tetrachloride, right? And many other examples are there. Trichloromethane. This is your chloroform, beta. Chloroform, the chemical which makes you to turn faint, right? Sorry, ethanol, ethanol, ethanoic acid. This ethanoic acid is your vinegar, nothing but vinegar. Urea, the chemical found in your urine, okay? Compounds containing organic compounds are covalent compounds having low melting and low boiling points. Clear? Let's move forward. Organic compounds occur in all living organisms, plant and animals. Mainly living organisms में पाए जाते हैं. Most of the carbon compounds do not conduct electricity, and yes, ये स्टोरी में आपको vital force theory वाला बता चुका हूँ. That initially it was assumed that carbon compounds cannot be formed, right? Okay. In the laboratory, और फिर फ्रेडरिक वोलर एक बार 1828 में हीट कर रहे थे अमोनियम साइनेट को. This is अमोनियम साइनेट, राइट? और फॉर्म हो गया यूरिया इसकी हीटिंग की वजह से. दिस वाज द फर्स्ट ऑर्गेनिक कंपाउंड आर्टिफिशियली सिंथेसाइज्ड इन द लैबोरेटरी. ऑलराइट, there are large number of organic compounds, beta. When you will come to see, it is 5 million, approximately 5 million, and still daily new compounds are synthesized. Reason for the large number of organic compounds, इतना ज़्यादा organic compounds होने के पीछे का reason क्या है? Let's see. पहला reason है उनका self combining capacity. वो straight chain में combine हो सकते हैं, वो branch chain में combine हो सकते हैं, या फिर वो cyclic form में combine हो सकते हैं. This property is known as catenation. अभी बताया था मैंने, right? Any doubt? Okay. And second property is their tetravalency, you can say. Yes, their tetravalency, they can form 4 bonds. All right. Now organic compounds, types of organic compounds, let's discuss. बेटा the types of organic compounds में हम लोगों को हाइड्रोकार्बन्स पढ़ने हैं, अल्कोहल्स, कीटोन्स, हैलोएल्केन्स, एल्डिहाइड्स एंड कार्बोक्सिलिक एसिड्स. ओके, सो लेट्स स्टार्ट विद हाइड्रोकार्बन्स. दरअसल हाइड्रोकार्बन तो ये है फर्स्ट, और बाकी सारे डेरिवेटिव्स ऑफ हाइड्रोकार्बन है, मतलब हाइड्रोकार्बन से ही बने हैं, राइट? इसीलिए कहा जाता है हाइड्रोकार्बन्स एंड डेरिवेटिव्स आर नथिंग बट ऑर्गेनिक कंपाउंड्स. Okay, let's see. Hydrocarbons, as the name suggests, these are nothing but the compounds of carbon and hydrogen. Students, I think on hydrocarbon I'll make another video. Okay, till then, keep learning, keep studying, keep watching the channel. Thank you. Stay safe, stay healthy.